share screen. And we're here. Or actually, it's better if we go.
There was a PowerPoint for that one.
Here, yeah. I don't know which is better. I guess PowerPoint's better. But it takes longer. Slideshow, current slide. Okay, welcome to Software Engineering, Chapter 2, Project Initiation. So we're going to learn about a project initiation document. We talked about it a little bit, but we're going to talk about more. This is actually going to be for the lab because you're going to have to write one of these.
How do the labs work in general? Like, where are they?
Well, the labs are just going to be a room with computers, and I don't know where it is, but according to your schedule.
The projects.
And we'll go there, and you'll work in groups on a project.
Okay.
But that you have to come for.
Well,
That I can't. That's not going to be on Zoom. That you have to come.
Last week you said we could.
I said we could do it on Zoom. Yeah, okay.
I emailed you like 3 months ago asking you if I could come to the lab.
You're right. I guess I forgot about that. You're right. Technically, you could do that with Zoom as a group, as a room.
As a group.
Yeah. Okay.
You say group, like group.
No, I mean group. 4 or 5 people.
And then so I basically. Can I come tomorrow?
What?
Can I
Yeah. Why, is your daughter?
Yeah.
Like I can't.
All right. Here we're doing a little, if anybody wanted to do philosophy or philology, you know what philology is? Philology is like the meaning of words, the structure of languages. It's kind of like part of linguistics. Philology is like if you write a dictionary, you're a philologist. Anyway, I think so. Logo is from philo in Greek means love. Like Philadelphia is the city of brotherly love, and philosophy is the love of wisdom. Philology, logos, is words, or we think of it as logic, but it also means words. I think the book of Luke in the New Testament says, in the beginning there was the word. The logos is the word in Greek. And logo, because so some people translate it as law. Law could also be law. But anyway, philology means the love of words. So if you want to be, so we're doing, here's a little philology. Methodology and technique. What is the difference between methodology and technique? So methodology is how to do something. Technique is how to implement that methodology. So we have to give some examples to clarify this. First of all, technique is more detailed. It can be different. There can be different techniques to follow the same methodology. So for example, make a list of the functionality of the system. That would be a technique, making a list. The methodology might be, here's a better example. The methodology might be object-oriented programming. Everybody in our company is going to follow the methodology of object-oriented programming. What techniques will we use? One technique we might use is to draw class diagrams. We don't have to draw class diagrams. We could just start programming in that, right? So the techniques are like how to implement that methodology. And actually, I have a good example here because there's another methodology which we're not going to use, which is called structured analysis modeling. This was before UML. Structured analysis modeling, we might use the technique called the data flow diagram. Actually, we are going to learn about data flow diagrams. You're not going to have to make them, but we're going to learn about them, and they could be on a test. DFD. In fact, when I told Abba Engelberg that this course teaches DFDs, he said, what? They still teach that? Of course, a lot of the things in this course are old, but so it's not so surprising that they teach it. So not so surprising that they teach it still, but it's useful. Data flow diagrams, we'll talk about it. But that is not in UML. If you look in the UML list of all the diagrams, there's no DFD diagram. There's no data flow diagram. So if we're using the methodology of structured analysis, we might use the technique of a data flow diagram. In UML, the activity diagram typically takes the role of a data flow diagram. That's a key line here. The activity diagram typically takes the role of the data flow diagram. That means nothing to you because you don't know what either of these things are. The activity diagram, do you know what a flow chart is?
Mm-hmm.
That is important to know what it is. Yeah, you did it in primary. I also did it in primary. You did it in primary school. But anyway, the activity diagram is basically a flow diagram. And the data flow diagram, even though it has the word flow in it, is a different kind of diagram. It's showing, actually, data flow diagrams exist in the world of business. I heard an interesting story from Carl Icahn, who was like a big investor. He bought once a company for millions of dollars in the 60s. And he came to their office in New York. They had several offices. They came to their office in New York. They had 7 floors of a building. And he said, what are all these people doing here? And he walked around and talked to people. And he could not figure out what all these people on these 7 floors of this office building are doing for the company. And so he decided to hire a business analyst who comes in, and he paid them $250,000 in 1960, which is a lot of money. And they do the whole analysis, and they gave him this huge stack of paper. This is what they're doing. He said, listen, I can't read this. I'll pay you. Here's your money. Here's your $250,000. Now tell me, what are they doing? And he said to him, honestly, we have no idea what they're doing. And so he fired them all. He actually talked to the other offices, and they found out that if he said, so should I fire these people? He says, if you fire them, I'll be able to fire 50 workers that I have to have just to take care of these people. So there's such a thing as business analysis, and they use data flow diagrams. Why do they use data flow? In other words, if you come to a system and you have no idea what they're doing, one way to analyze the system is to see what data is going in and what data is going out. Like, we'll treat the system as a black box and just see what's going in and what's going out, what data is going, who's supplying data and what data is coming out. And that gives you a rough idea of what the company is doing. And then you can start breaking it down. Okay, what does this section do? What data goes in here? So data flow diagram is to sort of describe the data flows of the various parts of a company or software. And especially if software mimics the operations of a company, which it will in an information system, right? Our software is mimicking them. Okay, so that's tools for, now that's just a slide on technology versus tools for software development. So there's something called CASE tools, C-A-S-E, computer aided software engineering. You might be familiar with these from other courses. Visio, Whitestar, Rhapsody. Rhapsody you probably don't know. No?
He hasn't used it yet.
You know, the Hanukkah Bohemian Rhapsody?
That was a funny one.
You know that?
No. It was the 613 one.
Yeah. I don't know. The Jewish on YouTube you can see a Jewish video. It's very good of the Bohemian. You have to first watch the Bohemian Rhapsody video, and then you can watch the Jewish one about Hanukkah. Anyway, Rhapsody is a software owned, now it was bought by IBM. It's basically, it's a really weird idea. You draw a model, you didn't do any modeling, you didn't do any class diagrams? Because this is like Mavbo. No, but you're supposed to have done like introduction to software engineering, and there you should have done.
We didn't do it ourselves. It was like we had diagrams and slides already made.
Those of us who took advanced operate.
Well, anyway, there's a course, I don't know if they still give it then, but maybe it's after this course, where you can take a diagram. Rhapsody is a crazy idea. You take a diagram of the classes, and then you press a button, and it creates the code. It can automatically create the code based on the diagram. Now, it's not going to really produce the code because it's not going to, like if you have a function and you just wrote in the diagram, you just wrote what the parameters are and what the return value is, right? In a well, you don't know, but in a diagram, you'll write maybe the parameters of a function and its return value, but not how it accomplishes its job. So the Rhapsody will create a function with the proper headers and all the structure, but the inside will be empty because you have to write the code. But it will give you the structure of all the classes, all the pointers that are necessary. That's what Rhapsody does. That's called a computer-aided software design tool. Whitestar is a more primitive version of that, which we're going to use a little bit, which is it doesn't actually do the code. It's just a nice way to draw stuff. It just allows you to draw diagrams. Now, an IDE is something else that you definitely have used, like Visual Studio. It stands for Integrated Development Environment. So the CASE tool is for creating a design, and the IDE is for implementing the design. Visual Studios you can do many different languages in Visual Studios, right? You can do C++, C#, Java. Oh, no, you can't do Java, but C#, C. NetBeans is really the IDE for Java. Eclipse is another IDE for Java or C++.
And you could do Java in VS Code.
In VS Code, maybe you can, yeah, maybe VS Code. Maybe, so maybe you can, yeah, I don't know. I'm just technically, I was saying, Microsoft is, it's like Russia and the Ukraine, Microsoft uses C# and Unix uses Java. So NetBeans and Eclipse are really Java type things. So what is an IDE? It comes with three things essentially: an editor, a compiler, and a debugger. You don't think of it as three things. You think of it as just one package, but it's really three things. The compiler is when you hit compile or build, and the debugger is for stepping through, and the editor is for editing. You could, like in primitive programming or in more like in more basic programming, you could do each of these things with different programs. So I could edit my program in one thing, compile it. Like I like to do it manually. I edit it in whatever editor I want. Then I compile it with whatever compiler I want, and then I don't debug. But it's nice to have the debugger together, and then it's easier to debug. Okay, so I'm just sort of jumping through. This kind of seems like a haphazard. Maybe it
When
is.
they say design, are they making like a graphic visual design of how your code works, or is it more like a
Which?
documentation?
Up here?
Yeah.
Yeah. No. Rhapsody, I'll draw diagrams. This is a class called dog. This is a class called cat.
Fine.
And there's a pointer, and the cat has a pointer to dog, and then you'll see a line pointing. And then you draw that, and then you'll get code that actually somehow implements it a little bit.
It's like a diagram.
It's from yes, Rhapsody. Now Whitestone just creates the diagram. Okay, now we're on to, this is actually perhaps the most important thing you should know, but you probably already know it. Sharing code with Git or Subversion. So there's this program called Git, and there's another program called Subversion. And what they are, anybody use them? Has anybody used them? Yeah, so you've used them. So you know what they are. They're for maintaining the source control. I can do lots of things with Git. For example, I can know who implemented a certain line of code. As we're working, see, it's one thing if you're working on your code by yourself, but imagine 1,000 people are working on the code, or even 5 people are working on it. And somebody wrote a new line and they added it, and now the whole system doesn't work. So first of all, we'd like to know who did that. Maybe you could go and edit his changes, fix it up. We could tell him, Michael, you have a code, you just put a bug in our system. Secondly, while he's working on it, we'd like the system to start working again before he finished it. So we'd like to do what's called revert. That means undo the changes that he did. And those changes are not just on his, it's like undo button, but it's undo for all the thousands of people that are using that code base. So it'll affect everybody. So that's very important. That's called version control. So I can say, what version are you on? Let's go back to the previous version. That's called version control. So there's something called Subversion and something called Git. Any software company that you work at that doesn't have this, you'll be the one who tells them to start using it and to implement it for them.
I don't think that exists.
What?
I don't think there's a company that doesn't use it.
That doesn't use Git? Yeah, well, there are sometimes situations where like the programmers will use Git, but you see, when you do coding, when you do QA, quality assurance, you also have automatic tests for it. So the people who write those automatic tests are the QA department, but they may think, oh, well, just tests. So those things, then they may not have that on Git. So then you may have to put that on Git. So you may find that certain things are not in source control. As you want to have source control on everything, not just on the software, on the testing software, and also on any files that you need, any let's say what's called configuration files to make certain things work. You would also put that into the source control. So somebody changes the configuration file, didn't change any software. He just changed a definition in a file. All of a sudden the system doesn't work. We want to go back to the previous definition. We don't want to just let these files be edited and not kept maintained. So a company may have partial use of Git, is what I'm saying, or partial use of Subversion. But you're right. Hopefully no companies would not be using Git. Project management. Oh, we're actually, this course, that's one of our main focuses, project management. We're kind of explaining what a project manager does. Because what does he want? Project manager doesn't want all the people to just be working and he has no idea what they're doing. He wants them to produce for him documentation. He wants them to waste their time and write documentation so that he can look at that documentation and see what people are doing. Because he's not, he or she is not well versed he can't keep track of what everyone's doing unless they write down documentation. So a project management requires documentation, documenting the requirements, the tasks, the requirements of the project, what we need to do, the tasks, the different tasks that are going to be assigned, bug tracking, keeping track of all the bugs, monitoring progress, and other reporting. That's project management. So I skipped a line here. Collaboration and task division tools so these are other tools. Azure DevOps, these I've not really used, but there is something called Azure DevOps, that's Microsoft's tool. There's something called, I don't know how you pronounce that, Kanban, and Jira. These are all different competing tools that don't just give you the Git source control, but give you these things. They also give you source control, see, allow collaboration, retain history. That's what I was explaining about Git. But they also give you a place to store your documentation, your task, and keeping track of tasks. Remember I told you last time about having Post-its on the wall and moving them around? So instead of doing that, you can do that with Azure DevOps in a virtual sense on a computer or with Kanban or Jira. So that's what we call task management. Bug tracking, keeping track of a bug. The QA department came up with 10 bugs. Now I got to assign the programmers to fix those bugs. I got to keep track. Did they fix them? Who fixed them? When did they fix them? I got to have bug tracking. All that stuff will be combined in these softwares. So you see, programming, what you're doing, what you've done is just, the first step is just the programming. But then there's the whole world of maintaining all of that programming, of making it, keeping track of it. Build and deploy. This is also a tool of these things that these latter things can supply. Which building and deploying, well, building I think means like compiling the different parts of the program. Deploying means actually installing it on managing releases. And that means managing how you install it on your different clients. People who buy your software, you may want to keep track of what special configurations each one of them needs. Maybe they have a different version. Maybe one person needs a special version of the software with special functionality which other versions don't have. So you want to keep track of your releases. Who's got what? All right, so those are tools that you should know about. Actually, there's a lab which we may or may not do, which uses this Azure DevOps, which you can download for free as a student, Microsoft, if you have a Microsoft account, you can download Azure DevOps. In fact, I recommend you do that and just sort of try to play with it. You're not going to break anything, so try to play with it. There's a lab which we may or may not do, which is a stupid lab, I think, kind of. It's just like create tasks and assign them and see that they're assigned. Just like sort of pretend like you're a manager and invent tasks and invent people. Basically, it's just playing around with Azure DevOps. So it's a good idea to play around with it. I do agree. As an actual assignment, I guess you won't do it as an assignment. So it does make sense to do it, but it's kind of a stupid assignment because it doesn't require it. It requires playing around with this tool. Okay, now we're getting into, all right, so those are just a few points. I talked about some tools, the case tools, the ID tools, the project management tools, this Git and the Azure DevOps or Kanban or Jira. And now we'll talk about project initiation. Project initiation is define what the project will do. You sort of make up a document that defines what it will do. You do this based on what the client describes and needs. In other words, he's going to tell you what he wants. So this document will act as a kind of contract between the developer and the client who asks for it. So that everybody, and the ideas have clarity, that everybody knows what everybody is doing. I know that I am going to do this, this, and this. And then you will expect those things, and and I'll also write in the document what I'm not going to do. I'm going to do this, this, and this. And this other three problems that we could solve, I'm not going to solve them unless you pay me more. I'm telling you now, this price quote that I'm giving you does not include solving those problems. So therefore, you can't come back to me later and say, how come you didn't solve the problem? I said, well, it's in the contract. So that's called this initiation document. It also provides another purpose, which is for like investors. In other words, I could come up with an initiation project, say, I want to do a software that does this, this, and this. Will you be willing to invest in my project? Do you think it's a good idea? And I'll try to convince you it's a good idea. You'll give me money and then I'll go and do it. So it's also could be used for investors. What will be provided by when and at what cost? Also has timelines. Okay. Now there's something called mafteach, which is an Israeli thing. This is similar to an SRS. We talked about SRSs last time. What does it stand for? I don't remember, but SRS is a, oh, here it says software requirement specification. I should really put that there. Take it away. It's software requirement specification. In other words, it says it's this initiation document essentially. So similar to an SRS is an Israeli standard template for creating a software project description. It's called Mafteach, and Mafteach is a Rashi Tevot for Mizgeret Pituach V'Tachzuka. Now, this was created by a company called Methoda, who is like a company that makes methodologies, I guess, and the Israeli Department of Treasury. In other words, the Department of Treasury wanted this thing because the country is going to have contracts, and they want to have, anybody who wants to give a contract has to follow, to the Israeli government, has to follow the Mafteach procedure. And then they can file a, bid for a certain job. And the company can compare all the different bids and choose the one that they want. But they all have to follow this Mafteach. And the Mafteach, I believe that it has many different definitions. Like if you want to build a bridge for the company, it also has in Mafteach, there's like a description for how to do a bid for a physical thing, like building a bridge or building a train station. But we're going to talk about the section of that contract, of that document that deals with software. Now you can say, why are we talking about such a specific thing? Well, at Machal Lev, they like people to know how things work in Israel, and people do a lot of, although probably none of you will work for government companies, but maybe you will. And a lot of people do, like work for Tasiya Avirit. I mean, I'm just thinking because you don't live in Jerusalem, they're usually more in Tel Aviv. But a lot of software is being developed for the army and for Ministry of Defense and for all kinds of, and for government agencies. So lots of programming companies, work off of the government. So then they have to use this method. I mean, whatever. The chances that one of you will actually work in a company like that and then become the designer who writes, and according to this, maybe. I mean, I don't know. I never had a student come back and tell me that he actually used this. But maybe you'll get one. But what, you?
My unit worked with them in the army. Like
with who?
Different, different.
They were worked with what?
Like there was a girl in my unit whose job was to work with different.
Mismachim.
Yeah.
Different mismachim.
Different
Okay.
people.
There you go. Okay, I got feedback. They still use this in the army. I want you to know. Thank you. So Mafteach defines several documents. That's what I was saying. A project initiation document, a specifications document, a design document, a coding document, a maintenance document. We're going to just do this project initiation document. I can do all of this. We will be focused on the project initiation document. So this is going to be in your lab. So I'm really explaining now. It's kind of some of the lab. Yeah. Okay. So wait a second. This is a kind of weird table. The system tree according to Mafteach, showing the life cycle of a project. So this is we talked about life cycles of a project.
Anywhere else in the world they use the same sort of method, or is this like a unique?
That's what I say. It's similar to an SRS. An SRS is an international the concept is the same all over the world, but exactly the definitions could be slightly different. But the concept, it's a type of software requirement specification. Specifies what the requirements of the software. So this is, you look, it's kind of a weird table to understand here. It goes, this is time or stages. The first is initiation stage. I would have put some, I don't know why I put it on the bottom. I mean, I think I copied exactly, translated it. I translated this exactly from a Hebrew table. And then probably put it on the bottom, but it should really be on the top. this is the initiation stage. Then there's the next stage is called specification. Like initiation is just saying is like proposing the problem. Then we do specify how we're going to do it, what exactly it has to do, what the requirements are. That's like specification. And then design how we're going to do it. Then we're going to evaluate what we did. I guess somewhere in between on this line here is the actual doing of the thing. And then maintenance, we're going to maintain it now that we finished it. So I guess the actual doing is sort of invisible here. So in the goals, here's how you read this. The goals at the initiation stage are only partially defined. But in the specification stage, they're defined, they're fully defined. And now we don't change them through design. Now in evaluation, we're going to check for compliance. Did we achieve the goals that we wanted to? And maintenance, we might make small changes. You see how to read that? And then, what are the features, application, the features of the application. I think I added that feature. The features of the applications. So in the initiation, we'll have a general idea of what the program will do. And then we'll have them mostly defined by the specification time. By the design time, we'll have it finished. And then we'll check it and we'll manage changes. Technology. Undefined, but constraints are defined. In other words, exactly what technology we're going to use at the initiation stage, we're not going to say. We don't know because we haven't yet gotten into the problem enough. But we may have some constraints. We may say, well, it can't use more than 2 gigabytes of memory, or it can't, we may have certain constraints on parameters within which we have to work. So in the technology, in the final definition, we'll have defined what architecture we're using. Like, are we going to use modules? Are we going to have one big software? How are we going to do it? I don't know what this means, purchase, but I'm not sure what that means. Maybe purchase external technology? Not sure. Check the purchase equipment. Oh, I guess you may actually, fine. Once you've figured out that we're going to do this project with Microsoft Visual Studio, then we're going to actually purchase Microsoft Visual Studio. So we have it. And then we're going to check that, we actually bought it, that we actually paid for it. I don't know. Implementation. So we have a preliminary implementation at the initiation stage. So you get the idea. Costs. We have initial estimates of the cost at the initiation stage, right? We're not going to know the final cost, but we are going to have an estimate. Then we're going to have an estimate. Then we're going to have a final estimate. Still, even in the design stage, we still have a final estimate. Then we're going to check that we haven't gone over budget. Then we may have maintenance costs. We may have extra costs for maintenance. Okay.
Wait, what did you mean by checking the purchase? Like you're checking if it works?
Yeah, or if we check that we actually did, I don't know. Check the purchase equipment. I guess make sure it actually does our job. It works. Yeah, I guess that it works. Yeah. Maybe that we paid for it. But I guess that it works, I guess. That it's, that it works. Maybe that we received it. Sections in the project initiation document. So now we're talking about the Mismach Yazum, and it has sections. So sort of similar. Goals, application, technology. Is it the same? Yeah. Wait. Goals, application, technology, implementation, costs. So in the initiation stage, we're going to make this, where are we? So what do we do in the initiation document? The standard defines sections and subsections and what their content needs to be. So we have these sections, the goals. We need to define the problems that the software will solve. So that's what you're going to have to do. So you guys in the lab are going to have to come up with an idea for a project. Actually, I have a list of ideas for projects. But a good example is like a travel agency. Software to run a travel agency. All the data that you're going to have to keep track of. What are you going to do? What features will you have? You'll be able to, person will be able to, for example, a new feature they have now on the internet, you can search 2 days or 3 days before or 3 days after the dates that I want. That's like, that's more than the minimum. You don't have to have that feature. So you'll define the goals, define the problem. So think about that example. Let's say you're writing software, remember information systems. I once had a group that like wanted to do like guidance systems, I wanted to do what Kipat Barzel. Kipat Barzel, yeah, what's it called? Iron Dome, yeah. Kipat Barzel. They wanted to do that. And I said, okay, but remember, it's an information system, not the real time. But they kept going into real time. They kept trying to say, okay, the launch missiles, check if you hit but that's not a good example. It's a difficult example. Because remember, we don't want anything real time. We really just want the documentation after everything happened. That would be, there might be an information system for Kipat Barzel, but it would be just like the after everything's been done, and now we just get data coming in from various people, and then we want to use that data to create documents. So a good example is really a travel agency, because they're just information, You you're going through all the flights and all the planes, all the locations, and getting the tickets, and you're just searching through data and producing data. So what are the goals? Define the problem that the system will solve. Application, what functions will it have? Who will use it? So in other words, what problem it solves. Remember, we don't write software unless we have identified a problem. Right? We don't just, nobody's going to pay thousands of dollars or hundreds of thousands of dollars for software if everything's fine. If his travel agent is making tons of money and he has nothing computerized, then don't break, if it ain't broke, don't fix it. We're only going to hire software if there's a problem. People are frustrated and he's getting bad reviews because he's slow or something, and then people are losing clients and ultimately losing money. Ultimately, all the problems are losing money, but there could be reasons why you lose money. So you have to define what the problems and how the system will solve it, what functions it will have and who will use it. In other words, okay, will the clients use the system? Will the people who want to travel to Tahiti use it, or only the agents will use it? And what functionalities will they have? What will they be able to do with the system? Technology infrastructure. What operating system is it going to be? Is it going to be a Windows machine? Is it going to be like, sometimes you come to, I was at, some stores, they still are on Windows 95 because they had software written for them on Windows 95 and it works. And why ever change it? And the only problem is now they've got to find if they have a problem, they got to get those old operating systems. So you have to define what operating system you're working on, what hardware you'll use. Implementation. So you have to decide who is responsible, who are the team leaders, who is in charge of integration, maintenance. Integration means, it's kind of like deployment, actually getting the system working on a client's machine. Cost, how much is it going to cost? The most of the cost is the salaries of the programmers. So we need to make estimates of these costs. How long, which means how many people. And we're back to that term we discussed last time, man months or person months. How many person months will this project take? Will it take 10 people, 10 months? So that's 100 person months. There is also a 0 section, which is a summary for the manager to read, because he may not want to read all the details. So we have like a summary in 0 before 1. By having set here's a key point also, I think, important point to understand. By having set locations for each topic, we know where to look for something and we avoid forgetting to include something, right? You say well, why write all this out and why have numbers for them? These are not just numbers, these are actually fixed numbers. Why have numbers for things? Well, it also allows me to compare to another document, another company that also gave me an initiation document. I can see, what did they say? I want everything in a certain structure so I know where to look for things and we can avoid forgetting things. So the initiation phase is something called the initiation phase. It's done by the business analyst or systems analyst or both. He or she needs to analyze the present condition of the system if one exists, the work environment, the existing technology, the time constraints. In other words, you need to, in order to do a software project, let's say for a travel agent, and they've never had a computer system before, you need to send somebody there to interview them and ask them, what do they do? How do they work? What data do they get? The goal is to try to decide if the project, if to do the project at all, and to convince investors to fund it. Data is collected from existing similar systems, similar documents, plans already written, speaking to workers at the, and market research. The final product is the initiation document. In other words, and that's produced really by the business analyst or the system analyst, this whole document, which he does by, talking to people, looking at other documents for the same type of system, seeing what other companies are doing, seeing what this company is doing. This is like I summarized really more slides that are in Hebrew, but okay. After getting the project initiation document, we might decide to do one of the following things. Either do the project, and then we're going to go to the specification stage. We're actually specify it. We might decide to not do the project. Or we may decide to improve the initiation documents, right? We may say, you know what, the way the project is defined, we're not going to do it, but let's change it, and then we'll do it. And maybe we'll do it. Then we'll decide. Cost analysis. See Hebrew slide section 2. I gave up on translating. So let's go to the Hebrew slides. No, it's the reason I gave up on translating is because it's the only one that I'm going to do this for. But because it's really just numbers and tables and things. So let's go to the Hebrew slides. What?
We obviously
We
don't need to know it.
don't need to know it.
You don't need to know Hebrew? No, I'm going to explain.
But if you didn't translate it, then
Obviously it's not important.
No, that's important. That's what you're gonna do it in the lab. So here, where is it? Don't worry.
Oh, it says Hebrew slide lecture.
Here, Hebrew slide lecture 2.
I was wondering why that was the only Hebrew slide there.
Yeah, I have one Hebrew slide here. And that's,
We can even get rid of the unnecessary slides.
okay. See what I translated for you? Look, see? Methodology. See, I translated this from the Hebrew. But I translated it into like 8 slides. Here, see? Computer aided software engineering. I translated it into 8 slides, and what they took about 26 slides to do. I didn't give you that beautiful picture there. Here, Yadim, Yisumim, Technologia, Mimush, whatever. This is everything we just did until slide 26. Oh, I don't have slide numbers. Here, I have that.
17. 22.
Business analyst, spelled badly. Okay. Here, software cost estimation. So I want to talk about this cost estimation. So first, let me just say before we start, so how did they come up with these cost estimations? What they did was they did backwards analysis. In other words, they took projects that already were built and they said, how many lines of code was this project? It was, and they measured it in thousands of lines. So it's called KLOC, kilo lines of code, KLOC. And they said, how many lines of code was this project? Oh, this project was 100 lines of code, or it was 100,000 lines of code. How much did it cost? $1 million. Okay. So every program has 100,000 lines, is $1 million. So each line costs, figure out it is. But then they say, wait a second. If another project that also had 100,000 lines of code, but it cost $2 million. So they said, well, what's different about these two projects? So they figured out what parameters cause projects to be more expensive and less. Said, well, this had a team of highly skilled people. This had a team of less skilled people. Or this was a project that was a real-time project. This was a system that. So this was a information systems project. So they came up with characteristics of projects, parameters of projects, which then influenced, which we call cost drivers, which caused the projects to cost more money or less money. And then they came up with a whole statistical analysis that they could figure out If I would know exactly how good the programmers are, and exactly what kind of project it is, and exactly how much innovation is required to do this project, and all the other factors, then I would know how much it costs. So we're going to learn about some of those factors. That's the introduction. Okay. So we have to decide the size of the project. That's the most basic thing we have to know. We could figure out the size by the number of functions, how much memory it has, how many lines of code.
How many lines of code till it's written?
No, what? You're right, I could have translated this, but I'm translating now. I guess what? I think it's gonna be numbers. Here, say it's numbers.
two of them.
But
What? Am I really scaring you guys?
Yeah.
Really?
I'm just tickling.
You're here for 3 years in this country. You must know some Hebrew. But just pretend it's Georgian or something, or Ukrainian. And,
Makes it worse.
I mean, just you don't have to know what it says here. I'm just telling, this is just for me.
We're doing this, we don't even know this.
What? No, you don't need to see the slides. Just pretend they're not there. And the slides are for me. What I'm saying, you have to write down or remember.
No, I have a question.
Yeah.
When they're planning a project, they don't know how many lines of code it's gonna be.
You're right. This is exactly the mystery of this whole subject. Somehow everything is based on the assumption that we know how many lines of code it's going to be. And we never could possibly know that. But maybe if you're programming for 10 years, you could guess. And if somebody asks you, write hello world, you could guess how many lines of code it is, right? If he asks you, write Pythagorean triples, a program to figure out the Pythagorean triples, you could guess that it's probably somewhere between 10 and 20 lines of code, or maybe 10 and 100 lines of code. It's not going to be 1,000 lines of code. It's not going to be 2 lines of code. So as you have experience, you could kind of guess, but it's true. How would you guess, a huge system, how many lines of code? So if you just finished 3 projects for the past 10 years, you've been working on 3 3-year-long projects, and you know how big they were and how long they took you. So you might have some idea. But you're right. As students in Machon Lev, you have no idea how many lines of code it is.
You
But
said you could also measure the size of a project with the number of functions.
yeah, here, these 4 things here. You could measure the size by how many functions it has. Mispar function, number of functions. How much zikaron, how much memory you're going to use. If you have some idea how much memory it's going to use. How many lines of code. And what the functionality of what the program is doing, how many things it does.
how's it different function?
And each of these systems have its advantages and disadvantages. The one that we're going to focus on, we're going to focus mostly on lines of code. Even though that's hard to know. Everything's hard to know.
Can you repeat the factors of lines of code?
Lines of code, how much memory, how many functions there are in the code. That's kind of dumb because I could have 1 function or 12 functions and they all do the same thing. I could have 1 large function and 12 little functions. So, but you could say,
Good programming.
like I'll tell you, when I was in my typing class in high school, I actually took a typing class. Well, I didn't. I was the worst student.
I took one in 8th grade, I think, or something like that.
Yeah. I needed to fill something in my schedule. I needed some credits, and I took this class, and I got a terrible grade because I can't do that kind of thing. I can't release, just not look and just type. So anyway, the way she would ask us to measure our speed was she would say, count a line, a row, count how many, it was words per minute. It wasn't letters per minute, words per minute. So count how many, take 2 random rows, count how many words are on it, and multiply by how many rows you have. So you can estimate how many words you typed, right? By looking at a row and then multiplying. So functions the same way. You could say, it's true, some functions, they can say, wait a second, some words are long and some words are short. So how does that tell me? Maybe I have maybe I'm translating some very high level English and it's got long words, so it's punishing me. And somebody else wrote, see spot run, and then it's shorter. So the answer is, like, statistically, it'll be about the same. So it's true, some functions might be longer, some might be shorter, but maybe overall, you can sort of get it. But the truth is nowadays we prefer short functions. So it may have changed over time, but yeah, what are you going to say?
No, I was gonna say that nowadays, they just have kids like do it in the game, and the game counts their words.
Yeah, you
Like,
can
that's
count it,
our,
right.
yeah.
This is to estimate the cost of the project?
Yes.
I think Word has a built-in thing where. you
Word
can
will
tell
tell you how many words, when you have to write when you have to write an essay for college, and you write your essay, Word will tell you you use 1,412 words,
That's right. Instead of,
which is very nice.
I did that for my college application essay, it's like you have to see. how
But
many-
when I wrote college applications, you had to just guess.
Yeah, but the person reading would have guessed too.
Yeah, exactly. So you can tell when because when the teacher says 1,000 words, he doesn't mean, write a 1,000-word essay. If it's 950 words, it's also good. And if it's 1,100, it's also okay. Okay, I mean 1,100 you might tell. Anyway, so this is in a table of let's see, the number of lines of code in a high-level language, the amount of time it will take to do it, and the cost. So, for example, I can say like this: if I have 1,000 lines of code, it's going to take me 300 hours, and it's going to take me $10,000. It's going to cost me 10 times that. Might cost. Look at that. This is interesting. Notice this. It's not a linear function. 10 times as many lines of code might cost more than 10 times the amount of hours and more than 10 times the amount of money.
What's the
Because-
first column?
What?
What's this column?
Number of lines of code, time, and cost
In a high level language.
in a high-level language. Because, right, number of lines of code in binary might be different.
I mean, what is this processing based off in general? Like how?
I'm just showing you what a table might look like.
No, I mean I get like, but in general, actually, different companies depending on the complication of your level, as in, is things ever based purely on how much code they.
So we're going to do a statistical analysis. We're going to take all of how do doctors work? How do they figure out that this medicine works? They take some people what? They take lots of people and they give it to them. What they like dosage. It was a big thing with insulin when they first invented insulin. They didn't know what the dosage should be, so they were giving people certain dosages and it was too much and it was causing other problems. They were getting all of a sudden other problems, so they gave them less. So.
It's like extracting
So here they
data
just
from a
take
lot of-
lots of companies and lots of projects and we sample, get all the data that we can and shove it into an equation and try to get shove it into an Excel document and see what equation comes out.
This is an example, or this is what?
No, this is an
research shows?
example. This is just an example. Okay, now, I guess I should have translated this. I could have translated it. Maybe, but no, it's pretty soon going to not, whatever. Okay.
It's all numbers.
I guess
All numbers.
I was giving up, I was getting so tired of translating this nonsense. Not nonsense. No, for me, anything that's not like binary programming or C programming is kind of dull. But I like math, that kind of stuff, or halakha, or philosophy, or what?
You said Unix used Java earlier,
I said what?
that Unix used Java.
Yeah.
That's not what you said in the Unix course.
I said use C++. C. Right, but Java is really for Unix. Yeah, Unix was written in C++ or in C. Unix, the operating system itself, is written in C, and C and C++ are the basis of. But Java is a more modern thing that was added to it. It's Unix, yeah. Whatever. I taught Java once. But many years ago. But I didn't continue. The school didn't continue. There was a period where the school went to Java, and then we went back to C++.
After the intro course.
Yeah. The way I taught it though was, I taught it according to the book and confused. Everyone thought Java would be simpler. It confused people though, because to do something very basic sometimes becomes very complicated, like printing "Hello World." Hello World in Java is not simple. You have a pane, whatever. You have to create a pane. You have to create a window, and then in the window write "Hello World." But there is a command line version. Whatever. Anyway, okay. This is not nonsense. This is very interesting stuff. But so let's go on. Sivug. So now, what is this Barry Bowen?
What's Sivug?
Sivug means the categorization of projects by Barry Boom, I guess. So here we're talking about small, big, large, very large, and giant. And we're talking about, this is how many operations it performs. I'm not sure exactly what it means by operations. It doesn't mean functions, but like if it does 8,000 operations,
Does it mean like machine language operations?
I don't know, actually. It's a good question. I don't know. Doesn't say anywhere here. I should look it up. Anyway, we're not going to do it according to operations. We're going to do it on lines of code. So let's talk about this, COCOMO. COCOMO is constructive cost model. COCOMO.
Is that what I think?
And what it is based on lines of code. And so we have this term,
What is it? Kokomo's construction.
constructive cost model. It means we're going to create the cost of the thing in a constructive way. We're going to construct the costs bit by bit, as opposed to just saying, eyeballing the number, saying, it's going to cost that. We're going to construct it. It's like in Wall Street, they have all these analysts that come up and they say, I actually had a project, I studied economics in a university in America, and I had a project to figure out what the price of the yen would be next year, yen to dollar exchange rate. Now, you could say anything. You could say it's going to go up, it's going to go down, whatever you say. But the main thing is that you have data to support your claim. So when analysts say this stock is going to go up, it's going to go down, they bring data and they show the data. And then who knows what will happen, but at least they had data. So, right? They have data and they can say why they're saying what they're saying. And if you ask them, why did you say that? Well, because interest rates, look at interest rates in Japan, look at interest rates in America, the interest rates are going up, they're going down
You
here.
can base it on so many different factors.
Yeah, but as long as you explain why you said what you said, then you can get on CNN and sound like you're an intelligent person. If you just say, I don't know, it just seemed like it's going to go up, then they won't put you on CNN and nobody will read your paper. In other words, you have to construct your costs. So when you want to say the project is going to cost $10 million, the president will say, well, why is it going to cost $10 million? I think it should cost, Donald Trump comes and says, why should the Air Force One cost $5 billion? It should cost $1 billion. I'm telling Boeing, make it for $1 billion. You know what I mean? And then it turns out in the end that the new project, was going to cost $7 billion. In other words, it actually went up. The original, in other words, you could just say, I want them to do it half the price. So they constructed the cost based on certain data, and it's not just a number. So we have to construct our costs. So and our method could be stupid or inaccurate, but at least it's a method. And we have to have some method. So
there has to be more of a science to it.
So there is a science. So the way we did it, like I said, go back to what I said before. They analyzed project. They said this project cost $2 million and it had 2 million lines of code. So it cost $1 a line. They went back and they analyzed. They took hundreds of projects and they figured out how in reality projects, how much they cost based on the number of lines of code. And based on other factors too. But the main basis is the lines of code. Okay. Here we're differentiating between different versions of lines of code. Delivered source instructions, delivered source line. We're going to focus on this one, just lines of code in a high level language. Do you count the line that says include?
It also depends, some people put the open brackets and close brackets and
Right.
lines and so,
Yeah.
four statements.
So we're being, we're being
They
vague.
be specific about the
We're not going to be that specific about that.
Okay.
You're right. You're right. It's a good question. When the code that they analyzed, was it with braces this way or with braces that way? Was it braces on the same line or on the next line?
Colors can be, I could trend.
Yeah, I understand. But we're not going to get so nitty-gritty. We're not going to actually, I'm not going to give you an exam. Here's 10,000 lines of code. How many lines is it? I'm not going to give you, here's a program. Tell me how many lines of code it is. You're not going to have to actually count lines of code, so don't worry about it.
Are we including the included? Or not including?
We don't care.
But why wouldn't they just have a standard?
Well, yeah.
But if you go across
language, they also had the same issue, like.
That's, it's like what I was saying, it's like what I was saying about, no, it's like what I was saying about the words on a line. You can take an average. Some, in other words, I could say like this, maybe some people who are working on the project will put blank lines in between their functions and some people won't. So on average, we'll get the same based on different companies. Of course, what if it's a company policy, which nowadays they do have, but in the time that they made this, they didn't. But nowadays we have company policies where everybody has to write their code in a certain way. The brace has to be, on the same line as the function name.
Plus documentation of the code.
I mean,
We got forced in one of our classes to use something called Doxygen.
right, the
Added
documentation.
a bunch of extra lines,
To your
nothing to
code.
do with the code.
So, but I think this system was developed at a time when there wasn't such rigorous supervision over how people coded. And therefore they came up with a kind of general average. Some people do it this way, some people do it that way. Anyway, so let's distinguish between,
Anything that you're not translating, we don't need to know.
what?
Anything that you haven't translated, we don't need to know.
No. Anything that's not on my section of the course comes on. But so far we didn't explain anything. You guys there's nothing, I didn't say anything really. I just said that there's such a thing as lines of code, and that is the basis of our course. Let's go on. This you have to know. I don't have to translate this because it's English. Organic, semi-detached, and embedded. These are three types of programs. Let's talk about embedded. Do you know what embedded means? Embedded means like a program for
An embedded system.
for an embedded system. So like an airplane guided system. That's software, right? It's embedded in the airplane. You're not going to put that on a PC. It's only for the computer in the airplane. Organic is a different type of thing. Organic means it's like organically created. It's like it's on its own, I guess. It's usually a larger project. In general, organic is the largest and embedded is the smallest. Let's see, we're going to define a little bit here. I take that back. Organic is the smallest. I take that back. Sorry. So organic are simple programs from the perspective of what they calculate, and they're small. So I take that back. Organic is small. Organic, I guess, why organic? It's one organ. It does one thing. It does one small thing. Examples are a system for managing a storehouse of a warehouse. It just manages the data in the warehouse.
Only one thing, or it's small, but not necessarily.
Well, it goes together, kind of. If it's small, then if it does one thing, it's probably going to be small.
Right, but could it be more than one thing, but it's still considered small?
Yeah, I mean, what do you call a thing?
I don't know, I have no idea actually.
Yeah, exactly. What do you call a thing? So here, the example that we're giving here is many things. Organizing a warehouse is many things to do in that, but we're calling that an organic system.
Like one job, but it has lots of
Parts.
parts.
That's organic. But you can think of it from the word organ. Like an organ, a kidney does one thing. It cleans your what does it do? Clean your blood? No, clean your water. Clean your, right? Creates urine, right? Your kidneys. So, but it does it in complicated ways. It does many things, but it does one thing. What is semi-detached? So he says Windows operating system is semi-detached.
What does that mean?
From reality.
It's semi-detached. What does it mean? Because it does more than one thing. It does lots of things, but it's not an embedded system. It's not for running an airplane. It's a general purpose thing, but it's does many things. Also, he has an example of a system for running a factory, running the machines in a factory. That's semi-detached. Let's see what embedded is. You can figure out what they are based on each other. What is embedded? So command and control for like a missile system, or like I said, or the navigation for a plane.
Like a washing machine also?
Yeah, also a washing machine. Here he has an example, a system that the stewardess uses to figure out the price of a good, calculate, I don't know, cashier. What a cashier system, maybe figure out what duties to charge or what taxes to charge. I don't know. That's an example he gives. That's a strange example. But let's say a missile system or a washing machine, that's embedded. Okay, so here's a nice table. We see in this table, organic, here's a simple way to define it. I actually wrote an example on the exam for the Israelis. I wrote like, which is true about an organic system. It typically has between 50 and 300,000 lines of code, or it has little innovation. Anyway, the dumb teachers of the Israelis said, you can't give that question because we said that the lines of code can vary. And I'm like, well, I got this table here that you produced. And that says on it that organic is typically, I mean, it could be larger, but typically between 2 and 50,000 lines of code. I thought it was a terrible question because like, make them memorize this table. But they didn't like the question because they thought that, then they ended up changing the question, but they still, whatever. The point is, organic is 2 to 50,000 lines of code. Semi-detached is 50,000 lines of code to 300,000 lines. Embedded is typically over 300,000 lines of code. Again, the best way to think about this number for embedded being large is not the washing machine, because how complicated is the washing machine? The best thing to think about is airplane guidance system. That's going to be complicated. You have to take wind factors into account, the angle of the wings, the flaps on the wings, the height, the elevation, right? Different elevations have different density of air. All these things you're going to have to calculate and then produce a number for you to do something to the plane, autopilot on a plane. That would be an embedded system, typically over 300,000 lines of code. So let's say, like putting the man on the moon, a large project requiring a large team for this guidance system for the plane. Innovation, a lot of innovation. Nobody ever wrote a guidance system for a plane before.
Innovation meaning like how much improvement?
How much innovation, in other words, how new is this? If I'm writing a system to run a grocery store, it's not much innovation because many grocery stores have systems already. But let's say if I'm writing a system to control the Mars lander, the ship that lands on Mars and drives around and runs so that might have more innovation.
These are 1,000 lines?
Clock, kilo lines of code.
They weigh them.
Kilo lines of code, 1,000 lines of code. And then deadlines and constraints. So that landing mission on Mars has severe constraints. I got to get the program to run on, a small computer because I want to have it lightweight to get to Mars. Development environment could be very complex. Could be a very complex system on that Mars lander. As opposed to organic, which will be small project, small team. Team is familiar with the application, the language tools used, little innovation, deadline, because if they're familiar with the application and the tools and the language, then whatever, if everything is familiar, then maybe there's less innovation. Deadline and constraints are not tight. The example I like to think about for organic is like a video game. A video game, because it's not embedded, right? It can, unless it's maybe it's for a Nintendo, but if it's for a PC, it's not embedded. And there's not really much innovation because, you're doing graphics and you just thought of a new idea, but it's not really innovative technologically. And you usually have a small team that does it, and it's not so big. That's the example I would think of. Semi-detached is an operating system. That's what they're saying, or an information system that you might make your projects in the lab are probably going to be semi-detached. Right?
You said a washing machine would be embedded?
A washing machine, in another course, I would say that a washing machine is an embedded system. It's definitely an embedded system. It just happens to be that it's a small embedded system. It's a very small embedded system, but it is embedded. You wouldn't say anything else because it's embedded in a washing machine. And that's what embedded means.
Said video games.
So it's a little bit these rules. This table is a table. Like I said, those teachers made this table. They published this table. You could argue with this table. This table is a generalization. Yeah.
You said video games would be like a semi-detached?
No, I think a video game is organic.
Okay.
I once read an article that said that the average size for a video game team that produces it is like 10 people. When you make something that's complicated but small like that, you want to have a very close-knit group of people that know how to work together. You're not going to have like 100,000 people working on it. Whereas you would to put the man on the moon, they had 100,000 people working on it. They had thousands and thousands of people. Now okay. So that's one thing. Or you need to know what type of project you're making. You need to know what the effort adjustment factors are, EAF. And we're going to see a table. I'll go right to the table. So the table is, you see why I didn't translate it, because look what I'm translating. This table has some Hebrew on it. I could have just, and I couldn't, that's why, because it's very hard for me to cut and paste. They don't have, they wouldn't, I don't know, I didn't have I just have the PDF. And I couldn't really, I don't want to start making all these tables. But this is a table of cost drivers. You see that? Which are things that change the costs. If everything is average, this green column means average. If everything is average, then it's 1. 1 meaning I multiply, here, we'll see, let's go to the equation right away. Where's the equation? Yeah. EAF, what does the EAF stand for?
Effort adjustment factor.
Effort adjustment factor. The effort adjustment factor is equal to, how much we adjust it to is we multiply all these different factors together. Now, if they're all 1, what's the effort adjustment factor going to be? 1. And then it has no effect. When we take the when we look at the EAF, let's go down a little bit. We take the EAF and we multiply it by the 1,000 lines of code and raised to the factor of B multiplied by A. But if the EAF is 1, then what effect will it have on how much effort it takes? None. It'll have no effect. Everyone sees that in the equation?
Go back to the other equation.
Wait, just understand this. The EAF, if it's 1, then the effort will be unaffected by the EAF. Now the EAF is the multiplicative product of these multiplications of all these variables, relay, data, whatever these are. If they're all 1, then the EAF will be 1 and has no effect. So let's go back to this table now. So now look at this table. And here, notice that the average is 1. So in here they are, relay, data, CPLX, all these things. These are the factors. If I say, well, in my project, everything is average. Well, then I have no change. Then then the cost will be exactly according to the statistics. Because I'm not modifying it in any way. That's why it's called an adjustment factor. How much do I adjust it by? So now let's look. Let's look at this table a little bit. So let's say, for example, I like to start with personnel. This is, by the way, a mistake. Notice the mistake here. It should be personnel with an E. Right? Not personal. Personnel.
And another
Which is bizarre to me. I don't know who wrote this. It's very nicely written. I doubt any of the teachers wrote it. but yet it has mistake. No, no, a lot of, I'm serious, in this course, I found, like, when I was translating some of this, remember I told you I couldn't get the pictures? So you know what I did? I like did Google search for the picture. And I found that all their pictures that they had in Hebrew, or they had in their Hebrew diagrams, but they were English pictures, they were all stolen from different places on the internet. So I stole them from the same place that they stole them from. I got the original ones instead of just taking their pictures. So like I said, when I say I doubt they wrote this, is like I doubt they wrote it, but it has a mistake in it, so I'm perplexed because maybe they did write it because it has a mistake. Okay, all joking. I'm not naming any names. Just besmirching everybody. Okay, so let's go on. Where are we? Yeah, so let's start with the personnel. If your program, look at this, let's figure out the logic of this table. Programmer capability. Do I have very capable programmers or do I have bad programmers? So if I have very average programmers, then it's just one. If I have very high, gavoa, highly capable programmers, then I multiply my costs by 0.86. What is that going to do? What happens when you take the number and you multiply by 0.86? Does it go up or does it go down? Down. So if I have very highly good programmers, then I multiply by 0.86, the costs go down.
Because you don't have to hire as many.
I don't have, the costs are going to go down. They're going to do it faster, right? If I have very capable programmers, why do I pay them more? Because they save me money. Let's take another example. Notice, okay, and if I have very bad programmers, it's going to make my costs go greater. Let's take another one, for example, here, main storage constraint. How constrained I am by how much memory I have. In other words, I can only use a certain amount of memory. Main storage constraint. Everyone understand that?
So that's consistent, like wow.
So here, let's say, if it's average, if I have very high constraints, as I have to fit it into a small memory space, then it's going to make my cost a little bit more expensive. I have to figure out a way of doing it with less memory. If it's extremely high, then it's going to all of a sudden start getting much more expensive. But if it's low, it's not going to save me much money. In other words, average, it's not going to have any change. Even if I have no constraints, I can use as much memory as I want. But memory isn't so expensive, so the fact that I have little constraints is not going to save me any money. Does that answer your question, Gabi? Now, sometimes it's the reverse. Notice these ones are high, the number went up. Notice that this example, the two examples I just gave you. Here, when it's high, it makes it more expensive. Here, when it's high, it makes it less expensive. Why is that? Because we're talking about high capabilities of the programmers. That's good. We're talking about high constraints. Well, that's bad. That's difficult. That makes things difficult. Language experience. Does my personnel have a lot of experience in the language that they're going to be using? So if they have a lot of experience, it's going to save me some money.
Isn't the same as.
But not much more. In other words, doesn't matter whether, once they know a little bit, if they're really experts, it's not going to save me anything more than the 9. In other words, this 9.5 is going to be the same here. This 9.5 like extends all the way to there. Even if they have super experience, not going to be much more than that. So there's some lot. Now, how do they get these numbers? They didn't just make up these numbers. How do they get these numbers? You tell me.
By checking the way it worked for other things.
Exactly. By checking the way it worked in other projects. They said, oh, this project was much cheaper. How come this project was much cheaper and it was faster done than this other project with the same number of lines of code? Because they had better programmers. I looked and I saw these programmers all have great ratings. And then there's other, I'm not going to go through all of these, but some of them are self-apparent. Analyst capabilities. In other words, the guy who designed the system, who's the analyst, right? Who came up with who analyzed the problem and came up with the design and everything. So if he's good, that's going to save us some money. If he's bad, it's going to cost us some Use, what does it mean, use project? Use of software tools. If we use a lot of software tools, that's gonna save us some money. Because we're not gonna have to do everything ourselves. We're gonna use tools that help us. If we don't like using tools, then it's gonna make our costs go up.
Is this assuming that the tools are free?
Well, we're not talking about that aspect. We're talking about, once I have the tool, you're right, I mean, yes, so we're not taking into account the cost of the tools, yes. You're right. In other words, maybe I use more tools, then it's gonna cost me more to use those tools. That's gonna be marginal.
But if you already have the tools and you're using what you already have, so then it will.
Exactly. We're not counting the cost of the tools. Use of modern practices. So obviously, if I use modern practices, the more I use them, presumably,
Modern practices meaning what?
whatever is the modern practice of the time. Using the better practices. In other words, remember we talked about like methodology and technique? If I use modern techniques, then that'll presumably improve my thing. Database size. If the final product, see, this is the product. These are divided up by what they pertain to. This is pertaining to the product. If the final product has a large database, has a very large database, it's going to cost me a little bit more. If it's a small database, it's going to cost me a little bit less, but not much. Doesn't have much effect. See, if you notice, the highest effects are, well, the highest effects are actually here by the hardware. Do I need expensive hardware? Okay, you got the basic idea of the table. Then this table, he just goes through a bunch of the examples here, time constraints, what these things are. I'm not going to go through all that. We went through some of it. Basically, you take all the things in the table, all those factors, and you multiply them. One might be 0.86, one might be 1.16. And 1.16 times 1.86, you'll get, and you multiply all together, you'll get a number. That'll be, maybe somewhere between, 0 and 3 or 4. Maybe it wouldn't be much more than 3, I suppose. I mean, it could be, if everything was terrible. But you'll get some number. Person months. He puts in person months or human months. The old term was man months. And let's just go straight to the equation. Wait a second. Actually, what does it say? Yeah. Man months, human months. I like person month. Yes.
Those are the same, right?
They're all the same. They're months. Months for assuming that men are human, then yes, they're the same. So effort, all right, let's look at this. Effort is measured in man months or in person months. So effort is measured in person months. So what do? We take the 1,000 lines of code that the project's going to be. Somebody came and told us this project is going to cost 10,000 lines of code. Okay? We're going to raise it to the factor of B. What's the factor of B? Are you guys taking notes? Or or just.
So effort measured is measured in human months.
Effort is measured in human months. So we're going to get a number here, which is going to mean human months. So first we take the 1,000 lines of code and we raise it to the factor of B. What's B? B is this column here.
What does it mean?
And what does it mean? It means if it's an organic, if it's a small project, we raise it to the power of 1.05. What is doing? If you raise it to the power of 1.05, you make it a little bit bigger. If it's a very big project, then we're going to raise it to the power of 1.2.
What does it mean? Where are these numbers from?
Statistical analysis of other projects. This is the equation that they came up with after trying to figure out why some projects of the same size are different costs. They figured, if you multiply the number of lines of code, you don't just take the number of lines as it is. First, you have to raise it to a factor of B. And then you multiply it by all these parameters that we gathered together in the EAF. And then you put a coefficient. Remember that nice word, coefficient?
They're all constants they came up with at some point.
They came up with through analysis of real projects. A, what's A? A is on this table over here. If it's organic, it's 2.4. Okay? That'll give me the effort. That'll give me how many person months I need. But I also want to figure out more things. I also want to figure out how many people I need and how long the project can take. So theoretically, the fact that I have 100 man months or 1,000 man months over here, or person months, doesn't tell me how long the project can take. So 1,000 person months. Maybe I should hire 1,000 people, get it done in a month. Maybe I should hire 500 people, get it in 2 months. Maybe I should hire 250 people, get it in 4 months. Right? I just know how many people months I have. How many people should I hire? So first thing we're going to do is figure out how long this project should take. So it should take this effort, whatever I got, 1,000, whatever, 1,000 per person months, to raise to the power of D. Now what happens when you raise something to a power which is smaller than 1? It gets smaller. It gets smaller. So I'm going to raise to the power of D, and I'm going to multiply it by 2.5. So I'm going to get some other number. And that's going to be the number of time t for development. That's how many months it's going to take, in months. Time not in seconds, but in months. Now, if I take the man months and divide it by the months, what am I going to get? What are man months divided by months? The months cancel each other out, and I'm left with men or people. So the staff, how many people I need? And if I get a staff of 8.5, what does that mean? It means 9. I can't hire half people. Maybe I can hire an orangutan.
Part-time,
What?
part-time.
Part-time. I could hire part-time, right? But in general, we round up. In this course, we'll round up. So you got this. This is called Kokomo. Now I saw that the Israelis added a new system, another system. Not the same one, but a slightly different one. And I'm not going to teach it to you because I looked it up and I saw that Kokomo was invented in 1972 and this one was invented in 1976. So I said, I'm not going to, if it's not from 2006, and if it's really new, then fine. It's like they just decided last year they did another one. And I'm like, silly. It's not any better. The point is you should know there are other methods of doing it. Okay, so.
Are we taking a break?
Yes. Oh yeah, let's take a break now, yeah. You know what we'll do when we come back from the break? We'll do an example. Isn't this fun? Math.
Along with the song I was talking about.
Oh, the canopy.